Welcome to Study Loop.
We need to find the value of this force at the point D, given that the length at A is equal to 3.6 meters. So we're going to start solving this problem by writing the equation for the length y of D. So we know that y of D is equal to the length c times the hyperbolic cosine of A divided by c. And we also know that y of D is equal to the length c plus h. So we're going to take these two equations, these two expressions, and we're going to equate them. So we get that c plus h is equal to c times the hyperbolic cosine of a divided by c. And the problem gives us a value for h and gives us a value for a. So we can plug in h and a and then take that equation and solve for c. So we can plug in h and then we can plug in a. And we can take this equation and solve it for the length of c. So we have this value of c. So we can take this and plug it into this expression, plug it into this term here, and we know what h is, so we can figure out what the length y of d is. So this length y of d is going to be equal to c plus the length h, which is equal to 6.07 meters. Now to solve for the force, this force is equal to the weight per unit length times the length y of d. And we can get the weight per unit length by taking the mass per unit length and multiplying it by the acceleration due to gravity. So this force is equal to the mass per unit length times the acceleration due to gravity times the length y of d. And this will give us a force that's equal to 119.1 newtons.